Hello everyone, welcome to the fourth lecture. In this lecture we are going to discuss about the view serializability of a non-serial schedule. Now in the previous lecture we have learned that a serial schedule always produces a consistent result. A non-serial schedule will also can produce a consistent result if it is somehow serializable. We have learned that there are two types of serializability. One is view serializable and another one is conflict serializable, where each and every complex serializable schedule is basically a view serializable schedule, but the vice versa is not true. The problem is that it is easy or there is a defined algorithm to find a conflict serializable schedule, but there is no defined algorithm to find any view serializable schedule. In this topic, we are going to discuss what is a view serializability problem and how we can determine a view serializable schedule by using some example. There are two types of serializability. One is view serializability and another one is conflict serializability. The conflict serializable schedules are always view serializable, but view serializables are may or may not be conflict serializable. So it is important to find the serializable schedules because it ensures the consistency of the database. And remember one thing, it is not possible to find each and every consistent schedule, or it is not always possible to check non-serial schedule is view serializable or not. Before going to the view serializability, let us understand what is view equivalent. When we are going to say two schedules are view equivalent, by definition, two different schedule S and S dash said to be view equivalent if they satisfy the following four properties. The first property says that same transaction participate in S and S dash with same set of operation. Obviously, if they are a same transaction, then the operations will be same. The second point is that if Ti transaction read the initial value of any data item A in S, then Ti must read the initial value of the data item A in S bar also. Now the third point is that for a data item A, if in S Ti performs the read operation of the data item A after Tj performs a write operation on A, then in S bar also Ti must perform the read operation of A after Tj performs the write operation of A. And the fourth point says that if Ti performs the final write operation on data item A in S, then in S bar also Ti must perform the initial write operation on data item A. Let us take an example and see how can we find the view equivalency of between two different schedules. So these are three examples, schedule 3, schedule 4 and schedule 5. All are non-serial schedule. So in schedule 3, there are two transactions, transaction 1 and transaction 2, and this is the sequence of operation. We have learned that reading and the writing operations are done from the database or to the database. Other operations are done in the buffer part only. So the database state changes when we perform either we read or write a data into the database. Otherwise, it does not change. So we are not going to consider from now on. We are not going to show all other operations. We only focused on the read and the write operation. Let us check that all three are view equivalent or any two are view equivalent or not. For data item A, which schedule is performing the initial read? Here T1 performing the initial read. Initial read, that term means that a transaction is reading a data item which is not written by any other transaction. So it is directly reading the initial value of A from the database. So T1 is reading the initial value of A in this schedule. For data item B, you can see that T2 is reading the initial value of B, right? but T1 is not, because T1 is reading the data item B after T2 is written that data item B. So here the T2 is reading the initial value of B. Now, which schedule is performing the final write operation of any data item? In case of A, T1 is performing the final write operation, and in case of B, T2 is, and in case of B also, T1 is performing the final write operation. The read and write condition need to be checked, obviously, because T2 is writing a value which is later read by the transaction 1, right? So this is the third condition which we need to check. Now let us check that schedule 4 is having that same property or not. Obviously you can see that schedule 4 is having the same kind of transactions, and all the transactions are of same operation. So the first condition, which is says that all the same transaction and same set of operation, that is satisfied. Then for data item A, which one is performing the initial read operation? T1 is T1 is reading the initial value of A. So this is true. Now for data item B, the transaction 2 is performing the initial read operation. Why? Because the transaction 1 is reading a data which is updated by or written by transaction 2. So this initial data read condition is satisfied for schedule 3 and schedule 4. Now what about the final write operation? Obviously for data item A and B, the transaction 1 is performing the final write operation for data item A, and for data item B, the transaction 1 is performing the final write operation. So that is also matching with the transaction 3. So the 3 condition has been satisfied. Now the last condition what we have to check is for the ordering of reading and writing. So let us check that is matches or not. Here T1 is reading a data which is written by T2. Here also T1 is reading a data which is written by T2, right? So that is also matched. So we can say that the schedule 3 and schedule 4 are view equivalent. Now what about the schedule 5? Schedule 5, which is the data item A and B, and you can see that all the 3 transactions, all the 3 schedules are having same kind of transaction with same set of operation. Now T1 is the data item A, initial value of data item A is read by the transaction 1, right? T1. Now data item B, the initial value is read by T2 in this operation, as well as it is read by the transaction 1 also. So you can see why, because it is directly reading from the database. Now as this is not matching with this or this, we can say that the schedule 5 is not a view equivalent schedule with S4 or S3. Let us discuss the view serializability. Now a schedule is called view serializable if it is view equivalent to some serial schedule. Let us discuss about the schedule 3 and schedule 3, which is the previous one, this one, same schedule, right? Now we have considered 2 serial schedules named schedule 6 and schedule 7. So let us first check S3 and S6. What are the data items? A and B. Which transaction performing the initial read? Obviously, we have learned that it is T1, and for B it is T2. Which transaction is performing the final write operation? That is, for A it is T1, and for B it is also T1. So this is for initial read and this is for final write. Now, which operation? Here we can see that the transaction 2 is writing a data which is read by the transaction 1. Now, in case of schedule 6, for data item A and data item B, which one is reading the initial value of A? Obviously, T1 is reading the data item initial value of A. Initial read is done by the T1. For data item B, here we can see that T1 is reading the initial value of B, right? It is not T2 because T2 is reading a data item B, reading the data item B which is written by T1. So there is a mismatch between these two. So S3 is not similar or view equivalent to this S6 serial schedule. So can we draw the conclusion it is not view serializable? No, we cannot because we have another option to check it. Here T2 is performing the initial data read is performed initially, then it will be followed by T1. Let us check with S3 and S7. So for data item A and data item B, which one is performing the initial read operation? For data item A, the T1 is performing the initial read operation. For data item B, which one is? The T2 is performing the initial read operation. T1 is reading a data which is written by T2. For final write, for data item A, which one is performing the final write operation? T1 is performing the final write operation. For data item B, which one is performing the final write operation? T1 is performing the final write operation. So these two this condition is matching, and similarly the first condition which says that with same the transaction with same operation, that is also matching. Now we need to consider which transaction for a write read combination, which transaction is reading a data which is by another transaction. So here data item B which is written by T2 is read by R1 at T1. Similarly here also the data item written by data item B written by T2 is read by T1. So that condition is also satisfied. So we can say that the transaction the schedule 3 is view equivalent to schedule 7. As S7 is a serial schedule, so we can finally conclude that schedule 3 is a view serializable schedule. Let us check that S5 is view serializable or not. Now remember, as S4 is view equivalent to S3 and S3 is view serializable, which we have proved, then S4 will also be view serializable. Now let us check that schedule 5 is view serializable or not. That with two transactions, the possible schedule is given at schedule 6 and schedule 7. Here the data item A is initially read by the transaction T1 and data item B is initially read by the transaction 1 and transaction 2, both of the transaction. But for a serial schedule, we cannot satisfy that condition. So as we cannot satisfy that condition, we can say that it is not a view serializable schedule. So let us check if there is any algorithm available for checking a schedule, non-serial schedule is a view serializable schedule or not. This problem is a NP complete problem, so there is a very few chance that any efficient algorithm is available to solve this kind of problem. So then what is the way to check a schedule is view serializable schedule or not? For understanding that, let us take an example given in the schedule 8. Now you can see that a different notation have been used to represent the schedule 8. The first operation is represented by R. R stands for read and the suffix 3 stands for transaction 3. So there are three transactions available 1, 2 and 3. So the first operation is a read operation and done by the transaction 3 and the read operation is done on the data item B. Similarly, the second operation is done by the transaction 3 and it is a write operation and it is writing the B data into the database. So these two operations, first two operation is represented in this tabular form of schedule for your better understanding. Now, the second two operations are done by the transaction 2 and transaction 1 and those are done on the data item B and data item A and both of them are read operation which are represented in this by these two. Now next two operations are done by transaction 2 and transaction 1, both are write operation and the data items are B and A which is represented here and here. Next three operations is a read operation by transaction 3 on data item A and the next operation is write operation on transaction 3 by data item A and the last operation is by the transaction 2 on data item A. Now we need to find it is a view serializable schedule or not. So there are three transactions available and the total number of possible serial schedules are factorial 3, that is 6. Those are listed here. This one represent transaction 1 will be followed by transaction 2 and followed by transaction 3. Similarly, the last one represent the transaction 3 will be followed by transaction 2 then followed by transaction 1. So first condition what we need to check is that all the operations of all the transactions are same or not. For our assumption it is same. Now the second thing, what should we check? Not initial read. First we are going to check which transaction is performing the final write on each and every data. Here you can see that transaction 2 is performing the final write on data item A, is also performing the final write on the data item B. So for both of the data item A and B, the transaction 2 is performing the final write operation. Now from that we can conclude that whatever the serial schedule it is, it should end with the transaction 2. It will eliminate 4 of the serial schedules and we left with only this serial schedule and number 5th serial schedule because in both of the cases it is ending with the transaction 2. Now then what we need to check? We are going to check the other two conditions, that is which transaction is performing the initial read. Then we are going to check for the write and read combination between the serial schedule. So if we perform that one, let us come to here. Here you can see that we are representing the schedule 8 here and we are representing another two schedule, that is schedule 8.2 which is the serial schedule and schedule 8.5 which is another serial schedule. The ordering of the serial schedule is transaction 1 followed by transaction 3 and transaction 2, and for 8.5 it is transaction 3 followed by transaction 1 and transaction that will be followed by transaction 2. Similar to the serial schedule we have identified which can be view equivalent to the schedule given to us, that is the schedule number 8. Now then what we are going to check? We are going to check which operation is performing the initial read operation on both of the data on A and B. So in case of our actual schedule on data item A, transaction 1 is performing the initial read, and for the data item B, the transaction 3 is performing the initial read operation. So which serial schedule is satisfying that condition? Now here you can see that the transaction 1 is reading the initial A and transaction 3 is reading the initial B. So my first condition is satisfied by the schedule 8.8. Now what about the schedule 8.5? You can see that the schedule 8.5, the data item B is initial value is read by the transaction 3, but in case of data item A, the initial value is read by the transaction 3, so which does not satisfy my condition that the initial read should be same for both of the schedules. So we from here we can say that the schedule 8 and the schedule 8.5 are not view equivalent. So from now on we are not going to consider this schedule. So we have left with only the schedule 8.2 to check with our to check view equivalency between our schedule, that is schedule 8. So we have matched our three conditions, that is all the operations are same. The second one we have checked that the initial write done by the schedule 2 in both of the cases, and the third condition we have checked is that the schedule 1 is reading the initial value of A and schedule 3 is reading the initial value of B. Then we are left with right read that combination checking. So this is the last chain condition for checking the view serializability. Here you can see that in transaction 3 the value of B is written by transaction 3 and that same value is read by the transaction 2. Let us check with 8.2. We are satisfying that one not. Yes, the transaction 3 is writing the value of B, which is read by the transaction 2. So this write and read combination has been satisfied. Then there is another write operation on B, but after that there is no read operation on B. Now, transaction 1 is writing the data item A, which is read by the data transaction 3 here. Now, let us check. Here we can see that the transaction 1 is writing the data item A, which is read by the transaction 3 in this operation. So, all of my four sufficient condition has been matched with a serial schedule. For schedule 8, we can say that it is a view serializable schedule, and the corresponding serializable schedule for schedule 8 is T1 followed by T3 followed by T2. Now, it may be easy to find a serializable schedule, which view serializable schedule for two or three number of transactions. But when the transaction numbers are high, it is very difficult to find corresponding view serializable schedule. If we want to find a schedule is view serializable or not, first we need to check it is a conflict serializable schedule or not. As we know that the conflict serializable schedule is itself is a view serializable schedule, so we can conclude from that the schedule will be a view serializable schedule. Now, if it is not a conflict serializable schedule, then we have to look for a special criteria. That criteria is called blind write. Now, what is a blind write? Now, you can see that here the transaction 2 is writing a value of A which is not read by it. Similarly, here you can see there is a blind write. So when a transaction writes a value for any data item without reading it, it calls a blind write. So our approach will be, we will first look for a schedule is conflict serializable or not. Now, if it is conflict serializable, we can conclude that it is also a view serializable schedule. If the schedule is not conflict serializable, then we look for the blind write. Now, if there is any blind write, then we can go further for the checking of the sufficient conditions. So in the next lecture, we are going to discuss about what is conflict serializability and how we can check a schedule is conflict serializable or not. See you in the next lecture.